Exponential equations are basically equations of exponents. So for example, this has exponential over here, so it's an exponential equation. Over here, this is an exponential equation as well because it has an exponent. So when we look at exponential equations, we should be able to still solve for x, and we'll learn how to do that. But first step, we need to learn how to equate indices. Now what that means is if a to the power of x equals a to the power of k, a and a, the base is the same, so you can equate the indices, meaning x equals to k. So that's what we're going to do. So for example, have a look at this. 2 to the power of x is equal to 8. Notice that their base is not the same, so you need to manipulate the data and change 8 as 2 to the power of 3 in order to equate them. So in our case, this case, 2 base is the same, so x must equal to the power, which is 3. So that's your answer. So that's what we're going to be doing, and I'll show you. So for example, let's do 25a. So we have 2 to the power of x equals 16. Now we can't solve it yet because the base is not the same. We have to make the base the same. So in order to do that, we need to figure out how to write 16 as a base of 2. So we write the factor trees, or you can figure out using a calculator. You can see that there's 4 lots of 2, so it's going to be same as 2 to the power of 4. So I can rewrite this as 2 to the power of x equals 2 to the power of 4. So therefore, my answer is going to be x equals 4 because my base is the same. So my powers must equate each other. Let's have a look at b. So I've got 3 to the power of x plus 2, so it's getting harder already. And I've got 1 over 27. So let's have a look at 27. 27 should be able to be written with different factors, different base, I mean. So 3 times 3 times 3, so 3 to the power of 3. So let's take a step forward. It can be written as 1 over 3 to the power of 3. Now, I can only equate them when it's not a fraction. It has to be both in the numerator, so I'm going to flip it up. And that means the sign changes. So that's going to be now negative 3. So now I can equate the powers. Base is the same, so that means my powers are the same. So x plus 2 must equal to negative 3. So that's what I'm going to write down. And now we can solve it because it's a simple linear solution. If I want to solve this, I just take 2 from both sides. So I get x equals minus 3 take 2, which is minus 5, and that should be my solution. Let's have a look at this one. So for this one, you need to manipulate both sides of the equation. So let's do 4x first. 4 can be written as 2 to the power of 2. So it'll be 2 to the power of 2 to the power of x. 8 can be written as 2 to the power of 3. So we can equate it like so. So as you can see, we've got our base, that's the same now. And then the powers are the same as well. Not same, I mean the powers over here. So you can equate the powers. Therefore, 2x equals 3. So if I want to find x, I just divide by 2. So therefore my x must be 3 over 2. Alright, let's do b. So b, if I want to manipulate that data, I can write 3 to the power of 2 instead of 9. And then x minus 2. And then in order to write 3 as a base of 3, I just flip it over the fraction sign so it becomes negative 1. I'm almost close. I just want to make sure I write this. What did I do? I tidied this up a little bit so it's nice and ready to be manipulated into data. So that will be simplified to 3 to bracket x take 2. So these bases the same. The powers must equal each other. So therefore 3 bracket x take 2 must equal negative 1. So in order to solve that, I'm just going to get rid of the 3 first. And and therefore my x take 2 must be negative 1 over 3. So in order to get x by itself, I just add 2 to both sides. So my x therefore equals to, whatever that calculation is, I'm going to borrow my calculator. So I get 5 over 3 as my x. So you should be able to do all of that questions now. Alright, solve for x. Let's do these questions. In order to solve this, I need to basically factorize and use the null factor law. And in order to factorize, I need to be able to use kind of quadratic equation, which is in this format. Okay, so as you can see, the c component is already a number. And as you can see, there's an x already there. But there's no squared part, and we'll manipulate this data to make it look like a square part. And I'll show you how to do that in a second. This is probably the hardest version. And with more practice, you should be able to do it easily. So let's write that into a base of 2. So 2 to the power of 2 is 4, and then it's got an x as well, so easy. And then I'll just keep writing the rest of the sentence. Okay, so this is the equation rewritten. Now what I need to realize is I can rewrite that component, flip it around, so write it as 2x to the power of 2. So I've just swapped these two around. And then I wrote 2x, and then I've got 20 and 0. So now it kind of looks like my quadratic equation. So I've got an x squared component, I've got an x, right? X squared, x, and a number. So all I have to do is think about, use sum and product to figure out minus 20. And then you need to figure out how many lots of 2x there is. Well, it's invisible, but there's actually 1 lots of 2x there. So you need to think about what two numbers you can times to get 20. So I'm going to write them all down underneath for you. So 1 and 20, 2 and 10, 4 and 5 is my option. So which two numbers, so these are my products, which numbers can you add or take in order to find this number 1? Well, this is probably my best bet, something like 5 take 4. I'm going to use that. So I'm going to write my x variable. You know, normally we'd write x, but instead of our x is that. So it's 2 to the power of x. And then you write take 5, or plus 5, because we want a positive answer. And then the other component would be 2 to the power of x, and then take 4. I'm going to expand this to show you that we get the same answer. Okay, so if I expand it, I get 2 to the power of 2x. So if you don't know what that means, it's 2 to the power of x times 2 to the power of x. Next one, negative 4 times 2 to the power of x, plus 5 times 2 to the power of x, and then minus 20. So if I keep going with this one, it's 2 to the power of 2x, because it's x plus x, and then I've got minus 4 lots of 2x and plus 4 lots of 2x, so it's going to be 1 lots of 2x, and then minus 20, which is, if I simplify it further, exactly the same as what we had as original over here. Okay, so I'm not actually completely done. I just wanted to show you that it's actually the correct answer. So now I need to go look back at this answer that we've written. So I'm going to rewrite it over here. We factorized it to make it look like this. And then we just got to solve it. So basically this equals 0. So we use the null factor law. We've done this using quadratic, so you should be able to do it. Basically this equals 0 and that equals 0. So we need to figure two answers out. So if I rewrite this first one, it becomes 2x plus 5 equals 0. So I'm going to write it as 2x equals minus 5. This one unfortunately can't have an answer. Okay, this won't have an answer. However, let's try the second one. So this one will give me 2x equals 4. And then 2x equals 2 to the power of 2. So if I equate the powers, my x is 2. And that's what I get. So you should be able to now do question 6. Okay, they're going to be pretty hard, so make sure you ask for support.